All right, Mr. Ahmed here for 6.1 part 3. Today we're going to work with powers of powers, and then also when we see our parentheses, we are going to distribute the exponent to every factor inside the parentheses. So what we're going to see here, to find a power raised to a power, I have 4 to the 6th raised to the 3rd. To do that, I multiply the exponents. So 4 to the 6th raised to the 3rd is 4 to the 6th times 3, 4 to the 18th. In a similar manner in variables, a to the m raised to the n, we'll see a set of parentheses, power raised to a power, I multiply m times n. I multiply the exponents. So, a couple easy ones first. X to the 3rd raised to the 4th, 3 times 4 is what we got to do. X to the 3 times 4, that's x to the 12th. Now we have r to the 2nd raised to the 3rd, that's r to the 2 times 3, power to a power we multiply, that's r to the 6th. Now with the distributive property here involved with this, we have to find a power of a product or a power of a quotient, we find the power of each factor, then we'll simplify, okay? So 3 and 2, those are factors. We're taking 3 times 2. So I have to take 3 to the 5th and 2 to the 5th, and that'd be 3 to the 5th times 2 to the 5th as a quotient. If that power is outside the parentheses, it gets distributed to every factor inside. So that'd be 3 to the 5th over 2 to the 5th. In a similar manner with variables, a times n raised to the m, a to the m, it gets distributed to both factors, okay? And same thing when we're dividing, a over b, raised to the m. Everything inside needs to get raised to that exponent, okay? Now keep in mind, as you're doing that, you are multiplying, because these are powers raised to a power. So our first example, 4 is a factor, so don't forget about this coefficient out in front. 4 has to get raised to the 3rd too, so that's 4 to the 3rd, and x to the 6th times 3, 18. Now 4 to the 3rd is not a very big number, so I'm going to figure out what that is. 4 to the 3rd is 64. So that's 64 x to the 18th. Now when we divide, again, this 3 has to get raised to every factor inside, both on the top and the bottom. So we'd have 2 to the 3rd, x to the 3rd, z to the 4 times 3, which is 12, over y to the 2 times 3, that's y to the 6th. Now we need to simplify this, okay? 2 to the 3rd is the only thing I can simplify. Nothing else has the same base. So 2 times 2 times 2 is 8, x to the 3rd, z to the 12th, over y to the 6th. So we will simplify after we're done. All right, you got that one. On to the next, 0 power. So we talked about this very, very briefly in the last video when I said, we're just going to leave that one sit because we haven't talked about it. So the 0 exponent rule just tells us for any non-zero number a to the 0 is always going to be equal to 1. Okay, a to the 0 is going to be equal to 1. We won't take 0 raised to the 0 power. That's undefined because that ends up being 0 times 0, or 0 divided by 0, sorry. So we cannot do it with 0. So for any number that's not 0, anything raised to the 0 power is 1. So, for instance, 4 to the 0 equals 1. X to the 0 equals 1. Okay? X just can't be 0. We aren't going to try and trick you on that. All right, we're going to assume if you see something raised to the 0 power, it's 1. So y to the 0 is equal to 1. X to the 3rd over x to the 3rd. We're dividing. Have to subtract the exponents. 3 minus 3 is x to the 0. That's equal to 1. Anything raised to the 0 power is 1. Now with this one, 4 does have to stay. Y to the 2nd over y to the 2nd. 2 minus 2 is y to the 0. So y to the 0 is 1. So this is equal to 4 times 1, which is 4. 4. That one was a little bit tricky because 4 isn't being raised to the 0. Only the y is, okay? All right, a couple you tries here, then come back and take a look, see how you did. All right, hopefully you did all right. Everything inside, including the coefficient, 4 to the 6th, has to get raised to this power of a power. 2 times 6 is x to the 12th. 5 times 6 is y to the 30th. 4 to the 6th is a pretty big number, so I'm going to leave it as 4 to the 6th. All right, next one, 3 to the 5th. X to the 25th, y to the 5th. Power to a power, multiply the exponents. It's a 1 over 2 times 5, a to the 10th. Let's see here. Is there any similar bases? Nope. 3 to the 5th. How big is 3 to the 5th? 3 to the 5th is 243. I'll find that. So that's equal to 243. X to the 25th, y to the 5th, over a to the 10th. Not too sure how picky Big Ideas is going to be with if you have to have 243 or 3 to the 5th here. If it's a small enough number, I would probably try and simplify it by finding it. 243 is not too big. All right, last one here. 4 to the 4th over, well, let's do the whole top first. 4 to the 4th, a to the 8th. B to the 4 times 8 is, I'm drawing a blank here, 32. All right, on the bottom, 2 to the 4th. 4 times 6 is a to the 24th, and b to the 20th. Now, we have to simplify this. 4 to the 4th is 256 over 2 to the 4th is 16. We'll leave it there. We'll call that good enough. Now with our a's, have to take 8 minus 24. That's negative 16, so there's 16 more in the basement, a to the 16th. 32 minus 20 is b to the 12th. So these ones are getting a little bit tougher. All right. That's it for today. Have a good one.